So today we're going to cover tutorial 1. Definitely finish it. I mean, as in like going through all the requested problems. So in the morning class, for question 1, I've gone through 1F. So 1F is effectively requesting you to evaluate the domain and range of the functions given. So if you look at 1F, I'll go through 1F with you first. Then if you have further requests for other questions, I can go through. So you see the story is here. Okay, so you can do it in multiple ways, because given the function f here, right, you are expected to evaluate the domain. But how to evaluate the domain is one of the ways is by looking at the x values, because the domain refers to the x values, for which you cannot define the function given. I repeat that. Yeah? So one way to evaluate the domain is to look at the values of x, for which your function cannot give you a defined number. So then you just exclude those x values away, and that forms your domain. That's one approach of doing it. And we have been doing it this way for reciprocal functions or rational functions. So we say that the denominator of the function basically cannot be 0. Okay? Because if it's 0, then you get division by 0, which makes the function itself undefined. So cotangent is simply defined as 1 over tangent, which is also defined as cosine over sine. So you can work with 1 over tangent, because you know where the asymptotes of tangent are. So the asymptotes of tangent are the same as the asymptotes of sine. Because, did I say that wrongly? Actually, I said that wrongly. Okay, the asymptotes of 1 over tangent resides at where sine, right, is 0. So you can see that if you have division by 0 here, then of course your 1 over tangent or cotangent will be undefined. So therefore I've written here that the domain is when the denominator here is not equals to 0. Because it's equals to 0, then it doesn't form part of the domain. So then all we need to do is to work out when is the angle not 0, or when is the angle 0. Okay, because you must understand that when you sign something, an argument, when you sign some stuff, that stuff is effectively the angle. So this sine pi x, right, the pi x itself is the angle. Okay, so the pi x itself is the angle. So therefore we just have to evaluate when is the angle giving you a sine projection of 0. But because we know that sine, right, is basically projecting the hypotenuse over to the y-axis. So this one I think I've drawn this drawing quite a number of times. Right? So you have your hypotenuse, the green line. So if it's lying on the x-axis, right, then you can see that the sine projection on the y is just a point. A point has no length. So therefore, that will give you a 0 for sine, for the vertical projection. So therefore from here, you can see that, oh, this angle must be 0 ma. Then after you rotate, the angle must be pi lah. But pi is also giving you the same projection of a point. So 0 value. Okay, but you can also go the other way. So if you go the other way, it will be minus pi then. Okay, then you can imagine if you have pi, then you rotate one more, or rather half a round more, get 2 pi. Then rotate half a round more, get 3 pi, and so on and so forth. So therefore, as long as your hypotenuse is at these angles, they'll be lying on the x-axis, which will give you the value of 0 for the sine projection or the y-axis projection. So therefore, pi x cannot be what? Cannot be 0 plus minus pi plus minus 2 pi, and so on and so forth. So therefore, we can abbreviate that to be n pi. Okay, because 0, 1, 2, 3, and so forth. And it can be also negative integers. So therefore, n here will be an element of z, which is all integers. So if pi x cannot be n pi, then x cannot be n pi over pi. You just bring the pi across. So therefore, x cannot be n. Okay, because n pi over pi is just n. So therefore, the domain of f is x can be any real number except integer values of n. That's how one can work out the domain for cotangent. Any questions with the domain? Basically what I did was just evaluate the asymptotes and then just exclude the asymptote values from the domain. So, and then the range of f is r. Why is that so? Because you have to consider for which, when the psi value here, right, give you a very small number. So if psi is a very small number, for example, very close to 0, which means that your x is very close to integer values of n. So you can imagine that as your psi pi x go to 0 plus, basically your function f, which is cotangent, is going to give you 1 over 0 plus. So 1 over 0 plus is actually positive infinity. 0 plus is like something that is slightly more than 0. I put 0 plus here. Right, this would mean a value that is very close to 0 but more than 0, like 0.00000001. So this is slightly above 0. Should be slightly, yeah? Slightly. Then this guy is actually slightly below 0. So slightly below 0 will be slightly less than 0. So like minus 0.00001. So if that's the case, then what happens is that you have 1 over a negative small number. So certainly your f will go to a negative big number. So that will be the range, because you can see that, right? You can range from minus infinity to infinity, including 0 itself. Because cosine pi x can be 0, ma? So if your cosine pi x is 0, 0 divided by anything that is not 0 will be giving you 0. So you can go from minus infinity all the way to infinity, including 0. So effectively it can be any value. So that's r. Any objections? Good. So do you have any other questions that you want me to go through for question 1? Any other parts? Because I think there are 7 of them, or there are 6 of them. So I'm not sure if any of the other parts you want me to go through. Because the answers are given there, so I'm not sure if you can get the solutions. Yeah, I noticed that my answer given for the last one is wrong, right? Should be x cannot be n, not m pi. This guy, so let me make a correction here. Okay, so it's n pi over pi, right? So it should be n, as we have worked out earlier on. What about any of the rest? A to E. Are you okay? Want me to go through another one for domain and range evaluation? Okay? Okay, great. All good? Okay, question 2 I think I won't do because this one is like similar, very similar to the lecture example. Okay, so to evaluate the equation of a straight line in all 3 forms, so I think this one you DIY, following the example from the lecture. Then question 3 I went through with the earlier class. Okay, not so much because it's difficult, but more so for the interpretation of the slope and the intercepts. What do they actually mean in the problem here? Right, so this is a problem from this OpenStax resource, which is the part that is given right here. So almost every tutorial towards the end, you will get the links given from OpenStax, for example, that guides you to the various pages, right, where you can find a lot more explanations and questions to practice on. So for example, you're, let's say, weak in trigo functions. You just click on that, and you come to this open resource. So trigo functions right here. So you can actually click from here, right, which other part that you are interested to learn more. So you can see, you can go through the explanation with the examples and so on and so forth. But if you're interested to get more practice questions, for example, on trigo functions, right, you can scroll all the way down, and then you can see under section 1.3 you have all the exercises. So then, if you are questioning whether you have solutions, well, there are solutions for alternate questions, right? So for example, question 131 here, there is a solution, right? Same for question 129. So all the odd numbers, they give you solutions. So if you click on that, then you will be guided to the solution for question 131, for example. Is that right? So basically you can get like hundreds or even thousands of practice questions here. Because not only you have all the questions here, then if you want more questions to practice upon, you can go to chapter review and then go to review exercises. As you can see all the review exercises here. So basically you get a good number of questions to practice, okay? As well as the information that is given, right, pertaining to the concepts. So this is a question that I extracted from OpenStax, okay, and this is what we call a modeling question. So modeling is just you're trying to get the mathematical representation for a word problem. So in this case, the word problem is simply some company purchasing some computer equipment for some value, and then at the end of a 3-year period, value of the equipment has decreased to a lower value. So what happens is that given the information, you can actually plot the graph as shown here. So the value of the equipment initially when bought is 20.5K. Then subsequently, it is mentioned here that it decreases linearly to 12.3K. So at the third year, right? At the end of the third year, so therefore you have this 12,300 as your coordinate. Okay, where the value here will be 12,300. So it says here it decreases linearly, so therefore we can just connect the 2 points by a straight line. Okay, so once you have the 2 points and then you have your line here, right? You can actually find the gradient, and then after that just derive your linear function v of t. Okay, so I suppose that's similar to the question 2. Then in part B, supposed to interpret the meaning of the slope. Okay, so the simplest way to interpret the meaning of a slope for any linear equation, right, or in fact for any function, is such that, right, because we know that the slope is this guy, this is the slope, mt plus c, so-called. So the slope minus 2733.33, now you got this from change of v over change of t. So it's always change of the y variable, the dependent variable, over the change of the independent input variable. So therefore, this must be what? Dollar per year. Why? Because your value is in dollar, so change in value is still dollars. Then your t is in years, so therefore change of t is still in years. So therefore, in this case, right, you are having dollar per year. So dollar per year really refers to the depreciation, the dollar depreciation per year. So that's what the minus 2733 actually means. And it's a negative value because it's depreciating. Any questions on the meaning of the slope? So slope, every time you want to like evaluate what actually the slope represents, really is just change in the function value over change in the input value. So then you look at what is that, what are the units, so-called, you just do a unit analysis, right? Then you look at the unit, then the unit will tell you roughly what it represents. Is that all right? Okay. Yeah, so talking about depreciation, one of the things that we always talk about in Singapore concerning depreciation is the ownership of a car. You probably know, right? Our car is ridiculously expensive because we have this COE thing. So if you know, if you haven't heard of it, I mean, the depreciation of a car in Singapore is easily $15,000 per year, because the car itself is probably 150 to 200 plus thousand. So you divide by 10. Of course, you get some scrap value back. After 10 years, you scrap your car, right? You get a pathetic like 4,000, 5,000, that kind of thing. So therefore, you are still depreciating most of the price of the car. So that turns out to be about easily 15K if you buy a new car, for example, right, and drive it for 10 years. Okay, so you just look at the depreciation value, 15K. Which are you able to? Do you want to spend that kind of money or not? It means it's costing you 15K just to drive that car for 1 year. Think about that. So you go over to Malaysia, you go over to Japan, you go over to Korea, go over to China. The 15K will bring you a new car for an infinite amount of time. Meaning to say, as long as the car can still move. So that's a big difference. Right? So actually the car is kind of like cheap, like maybe 15K or maybe 12K, that kind of thing. So if you go across, I mean, recently I went recently I went China, Yunnan, right? So I saw the car was on a road show lah. Then there's this BMW. Okay, I think it's a very big one. I think it's X3 or something. Then the listed price is 88 renminbi. 88,000 renminbi. 88,000 renminbi divide by 5, which is about the exchange rate from SGD to CNY, right? Divide by 5. It's about 18,000. 18,000 Sing dollars I can get a BM X3 down in China. Yeah, of course I don't want to think about that too much, so like make me depressed. So that's the thing about depreciation, and it's mostly evaluated when one wants to purchase a car in Singapore. Other than that, actually you don't look at depreciation so much, because like things that are dispensable, like food, right, or things that are so-called you can use up, you don't really look at the depreciation that much. Okay? Yeah. So therefore, let's look at part C, which is the evaluation interpretation of the meaning for the T and V intercepts. So the V-intercept is really straightforward. V-intercept is just your Y-intercept. So Y-intercept is really the initial value of your purchase of the computer equipment. So then what about the T-intercept? Now the T-intercept is the intercept whereby your function, straight line, intercept the so-called X or T axis in this case. So it's the root lah. Okay? So the root is when your V of T equals to 0. This is the point whereby your V of T equals to 0. That's why it intercepts the x-axis. So this is the year, because the root refers to the number of years, right? So it refers to the number of years when you have 0 value of your equipment. Okay, so in this case, T is equivalent to 7.5 years. So it's as good as saying, right, if you want to sell the computer second-hand, you have to do it before 7.5 years, or else after 7.5 years, you're not going to be able to sell the computer equipment for any number, any value. Is that all right? Can, okay? Because I think probably there's a lifetime, operating lifetime for the computer equipment. So then part D is really easy. You just set V of T equals to 30,000. You solve for T, you get the answer. Any questions on the, more importantly, on the interpretation of the meaning of the slope and the intercepts? Good. So, okay, question 4, I also did go through the earlier class. Okay, and it's not difficult because you need not do the completion of the square again because it has been done on the lecture slides already. Okay, but what's important is that the root that you get, so after you complete the square, right, on the quadratic function, you are going to obtain the root formula. So the root formula R12, so I put R lah, okay, representing root, you can put X or what, okay, doesn't matter. So therefore the root 12, right, is equivalent to this quadratic formula to find the roots. Now what's important is that, right, because you're trying to show that the vertex, which is the mean or max point of a quadratic function, is always at minus b over 2a. Okay, so because from the root formula, you notice that you can split into minus b over 2a, the red part, plus minus, then the green part, right, the green part is just root of this expression over 2a. So the understanding that you need to adopt here is that, right, it's really just one number plus minus the same distance d. Okay, so what does that mean? That means that the root is having equal separation of d from a central value. That's what this is representing. So there's a central value, you minus d, you get R1, you plus d, you get R2. Okay, so therefore it's a plus minus thing, right, when you have real roots or real and distinct roots. Okay, so the central value here must be given by minus b over 2a right here, because that's the one that you plus minus 2. So that has to be the vertex. That has to be the vertex. So because the vertex is always in the middle of R1 and R2. The reason is because your quadratic function is symmetrical across the vertex. No matter what you put for A, B, C, right, it is always giving you a smiley face or sad face, and that is symmetric. Is that right? Okay, so therefore that's the meaning of the first part of the question. You're supposed to show that. Right, so just make this drawing and then label this will do. And then for the application of that, right, you just apply to this equation. And you can get the vertex easily because A, B, C are all written here. So your vertex is really just 2. Then f of 2 is 4. So you just sub in 2, right? You get 2 times 4 minus 2. So that will give you 4. So 2, 4 is the vertex, is the point. Okay, on the vertex here. Is that right? So obviously this is not showing the same graph lah. Huh? Okay, this one is minus x square ma. So it's a set face. So which means to say that your fellow will look like it, will look something like that. And then at this vertex, it's going to be 2, 4. Is that right? Okay, so this is one way to solve for the mean or max point of quadratic. Then certainly if you have learned calculus, you can also get the mean or max point by differentiating f. So for those who know calculus, right, you can just differentiate f. Differentiate f, set it to 0 because the gradient is 0. When you differentiate, it means you are finding the slope or the gradient. So therefore, you differentiate, you get 2ax plus b. And guess what? If you set it to 0, you get x equals to minus b over 2a. It's the same result. But that will be maybe tackled after your topic 2, or rather topic 3. Topic 3, then we learn about differentiating. Any questions? Good. So, question 5, I did go through 5C upon request. Okay, then 5A and B, the answers are there, so I don't know whether you can get answers. Right, so 5C really, so evaluate the odd or evenness of the function, if any. Really, the first step is always to sub in minus x into x. Right, so just replace x by minus x, and you see if you can get any of the odd and even conditions illustrated in the lecture. So now if you have minus x, right, then you have a cosine minus pi x here, because previously it was cosine pi x. So therefore cosine minus pi x, right, is really the same as cosine pi x, because cosine function is even ma. Cosine function is an even function. So cosine minus theta equals to cosine theta. So therefore we just use that fact and then sub back. So then you realize that f of minus x is f of x. So therefore that satisfies the definition of an even function. So f of x is even. How about A and B? A and B, any problems? Good. So it looks like you're fine. Huh? A. Okay, so for A, same thing. So you always just sub in the minus x. So f of minus x. So f of minus x is minus x. So the x must all change to minus x. Minus tangent of minus x. Okay, so all x's change to minus x. But because tangent minus x or tangent x is odd, what? Because this one is something that we can observe from the graph, and also because tangent x, right, this tangent x equals to sine x over cosine x. So sine x is odd. So this guy is really odd divided by even. So odd divided by even is odd. Odd divided by even. So this guy is going to give you the result of tangent x being odd. Okay? So tangent x is an odd function. And this is probably clear if you look at the graph. Because I think this one we drawn the graph before, right? So the graph actually look like that, ma. This one is your tangent x. Then this guy is an odd function, because you rotate this guy across, you can get the other part of the graph. So this one rotate 180 degrees. So tangent x is clearly odd. And once you have tangent x being odd, right? So which means that this tangent x must be tangent x, or rather tangent minus x equals to tangent x. Oh, sorry, equals to minus tangent of x. So the thing about odd function is that this tangent minus x equals to minus tangent of x. So let me show you the graph here, because I drawn. So you look at the graph here, you'll see. So for example, if I have this pink odd function, you see the symmetry, I rotate this part 180 degrees, I get this part. So what's the deal here? The deal here is that, you see, minus x is here what? Let's say this is x, right? Let's say some value like 3 . Then minus 3 must be here, you just reflect across. Then let's say what's the f of minus 3? The f of minus 3 must be this number. Okay, I don't care what is this number lah. Let's say, for example, minus 5. Then if you consider, what about at 3? X equals to 3, for example. Then f of 3 must be here, what? Correct or not? So then this must be 5, what? So obviously, this is minus 5, must be the negative of this number. And the same goes the other way. This number must be the negative of this number, minus 5 lah. So this one is like positive 5. Okay, so you can see, right, just by inspecting the graph, right, you can come to this conclusion or come to this conclusion, but actually you just multiply by minus 1 to either one, right, you're going to get the other. So that's the deal about the odd function. And if you are fine with that, right, then you'll be able to solve this part already, because it's really minus x, then this is minus, correct or not? So it's a minus of minus tangent x. Cos tangent minus x equals to minus tangent x. So isn't this a minus x plus tangent x? But minus x plus tangent x is the same as a minus of x minus tangent x. So you notice that this is x minus tangent x. This is minus of x minus tangent x. So therefore this is minus f of x. So f of minus x equals to minus f of x. So must be even. So this and this will give you f of x is even. Any objections? Oh, sorry, it's odd. Not even, odd, because there's a minus. Thanks. Is that alright? 5B, You try it, right? Cannot, Okay, maybe I do here. Yeah, so it's the same procedure. You have f of minus x equals to minus x times 2 times minus x minus 1. So that's going to give you minus x times minus 2x minus 1. Okay? So if you try to manipulate this, right, you can factorize out a minus 1 from the bracket inside. So therefore this really can be simplified to x times 2x plus 1. So you go from x times 2x minus 1 to x times 2x plus 1. So then obviously the two functions are not the same, what? So this guy is not equal to f of x, because you cannot just anyhow equate the minus to plus, what? So it's not equal to f of x. Then secondly, right, it is not equals to minus f of x. Because if you have a minus f of x, right, then there must be a minus here. Okay, minus here, but this will still be the same. But you can see that this is a plus. So therefore, this will be giving you neither even nor odd. Is that right? Okay, so if you plot the graph, you will be able to see the unevenness. I can tell you just by looking at this, right, you probably can tell, because this one, the root is at x equals to 0 and x equals to half. So if you try to plot this quadratic function, and this is a positive coefficient 2, right, for x squared, so therefore it is a smiley face. So therefore the graph actually, so these are the roots, x equals to 0 and x equals to half. Okay, so which means that your graph actually looks like that. So this is neither even nor odd, because it's not reflected across the y-axis, what? It is not a reflection. It's not a reflection over the y-axis. And it's neither a rotation. You can see this part, you rotate about this point, doesn't give you this part. You understand that? So there's no rotation symmetry, there's no reflection symmetry. So therefore, neither even nor odd. Sorry? This one? From here? Actually, you can. Now the deal is that, right, because usually what we try to do is to manipulate this expression into a simpler or simple enough form such that we can compare to the original function. Okay, so you can see that this is a positive. Okay, actually you can just leave it like that. Because obviously, right, this minus 1 is the same, but there's a minus here that is not the same. So therefore, from here, right, you can just write this thing. So neither even nor odd. Any other questions? Yeah. Sorry. Yeah. Yeah. Cannot. Okay, the deal with the oddness and evenness of a function is that you must consider the entire function. So if you just sub in one point, right, you only show that, oh, maybe the function is even for that particular point. So point-wise is for you to check. Like, wow, very difficult to manipulate. Never mind, you sub in +1 - 1, for example, +2 - 2. You sub like 2 points, then you see, the value, is it the same? Then chances are the function can be even. Correct or not? If it's like negative of each other, right, then we know that, chances are the function is odd. Then I can understand. But when you show, you cannot just show for a discrete number of points. So therefore, you have to work with -x, because x can represent any input in the domain, of course. Okay, so that's the deal with mathematical proving, right? You have to be a bit rigorous here. Okay, but when you check, let's say after you get, oh, this function is even, okay, then I just sub in a few points. I see if I get the same number. If I get the same number, then more or less I'm correct, So that one can be used to check. Any other questions? Okay, good. So question 5, we are done. Okay, so question 6, I only got requested to go through F, which is also the neither even nor odd case. So maybe just reiterate. So you can see that, as usual, I just put the x become -x. Then all the x's in the F even and F odd must also change to -x. But because even function, f of -x equals to f of x, so nothing much. This is the definition of the even function, so I just sub inside. Then the definition of the odd function, I also just sub inside. Okay, so now what's the deal? The deal is, right, you look at this guy. This one is a plus, this one is a minus. So how can they be equal? So obviously they're not equal. So w of -x is not equals to w of x. So not even. But if you try to factorize out a minus, right, you also cannot get negative of this. So therefore, it is neither equals to minus w of x. So neither even nor odd then. Okay, and this is evident from if you just mess around with like two sample graphs. So I show you. Okay, so what's a simple even function? Constant, correct or not? F even of x equals to constant c. Okay, constant is an even function, obviously. F of minus x equals to f of x for all x. Even function. Then what about odd function? Odd function, maybe you say that, y equals to x, simple function. So f odd of x equals to x, let's say. So now if you try to add f even to f odd, what do you get? You get a function for x being shifted up by c. Okay? So now you observe. So this guy is w of x. Now, how is this even? This one, it's not reflected here. The other guy is here. It's not no reflection symmetry. So therefore, it's not even. Then is there rotational symmetry? So if you try to rotate this part to here, right? That means rotate 180 degrees. By right, this part should come to here. But it's not what? It's here what? So therefore, it's neither even nor odd. It's also not odd. Okay? So therefore, even plus odd, right? The general consensus is it is neither. Okay? Unless your even function is the zero function, it's like f of even equals to 0. Then okay lor. Right? But generally, right, it is neither. Okay? Unless for special cases. So that's for question 6. Okay, so question 7, I think the earlier class requested me to go through, right? For both A and B. So I'm going to go through the same stuff again. Okay, so the story is, because you are trying to prove the sine rule or the law of sines, so what happens is that sine, because they tell you sine already, so sine means what? Sine means opposite. Okay, because opposite over hypotenuse is sine. So therefore, I just try to draw some opposite. Okay, so you can see that there's two angles here, right? Beta and alpha. So where's the opposite? This, okay, this pink line. You see, So therefore, you're trying to form a right angle triangle that has opposite that is opposite to alpha as well as opposite to beta. So I call this opposite to alpha and beta. Yeah. So of course I can write down. So opposite is equivalent to hypotenuse sine alpha. That's the first guy. But opposite is also A sine beta. A sine beta. So it's the same opposite, what? So therefore, I equate them. Then after I just rearrange, I get the first equality being shown. But you only work with one opposite, right? There is other opposites also. For example, this is the opposite to alpha as well, okay, pertaining to the length C, because this is also one big right angle triangle. Can? So therefore, this is opposite of alpha, but it's also opposite of phi. So phi is this angle, okay? So this angle phi, right, is really just pi minus gamma. This is gamma, okay? So it's just whole thing pi, 180 degrees, minus gamma. So therefore, we can do the same trick, right? So opposite is equivalent to C sine alpha, C, the hypotenuse, sine alpha, I get this, opposite. But it is also equals to A sine phi. Correct? It's the opposite angle to phi, what? So A sine phi is also giving me this opposite length. Then phi is actually pi minus gamma. But when you sine pi minus gamma, you sine gamma is the same stuff, what? You sine gamma, you are going to get this value. Correct? Let's say A is your hypotenuse, it's your radius, right? So when you sine gamma, is this obtuse angle, right? So what are you finding? You're finding the projection that is onto the y-axis. So this is your opposite, okay? But it's exactly the same if you were to go and sine phi. So sine pi minus gamma is giving you the same value as sine gamma. Okay, so this is from the understanding that sine is just the projection of any radius, any hypotenuse, onto the y-axis. That's all. Okay, so if you don't believe that these two values are equal, right? You can just press your calculator, or you can check. So sine A, then sine pi minus A. You see the two values are exactly the same for all A. You see? So I don't care what's A, what's the angle A, right? You sine A or sine pi minus A, right? It's the same thing, because you are just looking at reflection. So let's say if this is pi minus A, so what is, so if you are like sining pi minus alpha, so what is sine alpha? My bad. If you are sining pi minus gamma, okay? So let me draw the acute version so that you can see the thing more clearly. Okay, so let's say this is your hypotenuse. So this angle is what? Let's call this angle gamma. So then I ask you the question, where is sine pi minus gamma? Then pi minus gamma is just here, Okay, I find a nice color. So this is just pi minus gamma, what? Okay, so this angle is pi minus gamma. Okay, taking with respect to the same x-axis. So it's a V shape, So this is gamma. This must be pi minus gamma. Okay, you can see this big angle, right? Because this gamma, opposite angles. So the whole thing is pi. So therefore, this obtuse angle must be pi minus gamma. Okay. So therefore, what's the thing about sine? Sine is that, you just find the coordinate or projection that is onto the y-axis. Simple as that. So therefore, you can see that it's going to give you the same projection, which is this point. Okay? So this point is going to be sine gamma, which is also sine pi minus gamma. Okay? Because it's just projecting the hypotenuse length, right, onto the y-axis. Right? This you project here and you project here must give you the same thing. Because the thing is like a symmetry, having this symmetry about the y-axis. Is that right? Okay? So this part is just trying to show it here. So this part, you can see it here. So if you agree with that, then really just equate this to this. Then after you shift terms around, you get the first equals to the third. So if first equals to second, and first equals to third, then second must be equals to third. So you have proven the entire equality. Then talking about this question actually brings me to your physics or your kinematics or your dynamics. You all got learned the resolving of forces? Gone through already? So if you are good with this, right, sine cosine thing, right, then I can give you any force, any angle. You should be able to give me the resolved forces in a snapshot. Okay? So test you. So let's say a force like that, F. Then let's say I have this line. Okay? So I say this is angle theta. So now I want the force F that is projected onto the pink line. So what is the force? The component of the force that is along the pink direction, the pink line direction. So what is the component? Tell me. Huh? Tell me, what's the component? Sine theta. F cosine theta. So basically you draw triangle. Then after that you just project the force downwards onto the pink or whatever direction that is given. So isn't this F cos theta? Because it's adjacent what? Adjacent must be cos already what? Can ah? Okay? So then you always have this thing. Like that. Then after that you say, oh, there's some object, there's some mass, M. Then there's a weight, F, W. So I want to find what's the component of the force that is along the slope. Okay? Then maybe I give you this angle, theta. So therefore then, isn't this about the same as this? So you just project. So you draw triangle, right angle, triangle, right angle. Then this thing project here. So you can see this thing is adjacent to theta ma, so it must be W cosine theta what? Okay, okay, but then I can give you the other angle. What if I give you this is phi? So I ask you, hey, what's the force here, right, pertaining to phi? Then you tell me this one is equivalent to F sine phi ma? Correct, huh? Okay? Yeah, so therefore, after you learn about the projections, functions, right, cosine and sine, by right, you should be able to do the resolution of the forces quite quickly. Sorry? This side, 90 minus theta, sine 90 minus theta. It is. It is. So what he's trying to say, right, is that if you use sine instead, it's actually 90 minus theta. Okay, what's the reason? Because it is 90 ma. So let's say if I have this angle phi here, right? So phi is equivalent to what? 180 minus 90 minus theta. So the end result is 90 minus theta. Okay, 90 degrees in this case, right? So clearly this is also equivalent to W sine phi, and therefore W sine 90 minus theta is the same thing. Okay, so yeah, so that's the thing about projection functions or trigo functions. Okay, so second part for question 7, law of cosines. You're supposed to prove the law of cosines. So then this guy is really using Pythagoras, which is illustrated here. Okay, so the deal here is that to apply Pythagoras, you need to firstly draw the right angle triangle first. Okay, and then you need to involve, because if you look at the Pythagoras formula that is supposed to be shown by you, you notice that there is a gamma. So we are working pertaining to the angle gamma. Okay, so you have to involve angle gamma in your right angle triangle. Okay, so you have to use this big right angle triangle, right? Because this side is A sine gamma. This one we explained earlier on. Okay, is A, then projected onto this point. So therefore this point, the length, right, is actually sine gamma. Then this part must be A cosine gamma. A cosine of gamma is going to give you this point. This point lah. But this point, because your gamma is obtuse, more than 90 degrees in the second quadrant. So therefore your x must be a negative value. So what is the whole length here? So the whole length must be this b plus this length. But because the coordinate is negative, so therefore you have to put a minus. So minus of this minus, so that you get a total length. So therefore you have labeled the three lengths already, right? Opposite length, adjacent length, as well as hypotenuse length c. So when that happens, you just use Pythagoras, then work out, then explain out. Then after you make use of sine gamma plus cosine, sine square plus cosine square equals to 1. So therefore you can rearrange and get the cosine rule shown. Or why is it b minus? Okay, because when you cosine an obtuse angle, right, it will always give you minus. When I say obtuse, means in the second quadrant or in the third quadrant. Because the deal with the cosine function, right, is that it is projecting onto the x-axis. You see that? So this is my hypotenuse. If you project onto the x-axis, so in the first quadrant you are getting positive. Because it's always the x coordinate that give you the cosine. So this one is like cosine theta. Let's say this is theta. Okay? So then, what about if you are in the fourth quadrant? So fourth quadrant also okay. Fourth quadrant, right, you still get positive. Fourth quadrant can be any angle. in the fourth quadrant. Okay, so like if you cosine a number, right, that is between 270 and 360 degrees, you are getting positive value. Then if you go and cosine in second quadrant, then obviously you get negative number, right? Because this one is a negative number. So therefore, if your angle right, is in the second quadrant, so between 90 and 180 degrees, then you are getting negative. But it's also the same for if your angle is in the third quadrant. So if your angle is in the third quadrant, you also get negative. So you can pretty much press the calculator to check lah. So which means from the angle of pi over 2 to 3 pi over 2. So if you cosine this part, you'll get a negative value. Cosine pi over 2 to cosine 3 pi over 2. Then if you cosine 3 pi over 2 to pi over 2, this part, first and fourth quadrant, then you're going to get a positive value for cosine. Is that right? Okay, so therefore, going back, so this guy is a negative number because my gamma here, right, has obtuse angle. That means it's in the second and third quadrant. You can see the radius A here, the hypotenuse, right? So therefore, this is minus. So then I cannot put B plus A cosine alpha, A cosine gamma. If I plus, then this one is a positive number, then this one is a negative number, then it becomes shorter length, meh? Wrong, right? So therefore, I must minus, so I make this a positive. So therefore, I get B minus A cosine gamma. Is that okay? So that's for question 7. Let's look at question 8. Okay, question 8 DIY, because they didn't ask me to go through any part of it. Do you require to go through A or B? Or you're fine? You're fine, then you DIY? Good. Looks like you can DIY. Question 9. So question 9, I only got requested to go through part C. Okay, which is to find the inverse of the function and its domain and range. So here comes the story. Okay, so to find the inverse function is a standard procedure. You just let y be equal to the given function. Then your whole point is to get x. That means you have to isolate this x out of the equation. Why? Because of the notion that x fit into the function will give you y. Y fit into the inverse function will give you x. It's because of this thing. Okay, I repeat again. X fit inside the function f will give you y. Y fit into the inverse function will give you back x. So therefore, you see what actually we are doing here. If you let if you let y be the given function f, then what is it that you want to obtain? You want to obtain f inverse, ma? So if you want to obtain f inverse, then you obviously have to get x, what? Because x equals to f inverse of y, ma? You can see f inverse of y, then you get back x, what? So x equals to f inverse y. So which is exactly what we are doing now. So we isolate x, so therefore we can get our expression in y, which is f inverse of y. So then the rest is like algebraic manipulations. So this one I think you can go through yourself. Just shifting terms around. Then, because usually they want f inverse of x, because x is like your input lah. So therefore they want like, oh, can you give me the inverse function using x as the input? So if that's the case, right, you really just need to replace y by x. You can see this f inverse y, so that we get a y inside here. So f inverse x, right, you just replace x. So I'm saying this. So therefore, when this is x, or any other alphabet, you just change this to the alphabet that you want to use. Simple as that. So that's the inverse function definition. But then what about the domain and range? So the domain and range, right, you have to analyze the function given. You cannot analyze the inverse function directly. Why? So it's like, this guy depends on this guy, leh. Because it's the inverse function of f, ma, so f is the so-called originator. Okay? So therefore, you got to analyze the range and domain of the originator, and then just flip it. Okay? So the domain is already prescribed for you. Okay? So this domain is prescribed so that your sign has an inverse. If not, right, your sign being a periodic function is not one-to-one. So no 1 to 1 cannot have inverse because it doesn't pass the horizontal line test. So hence, this is the domain. So domain of f will instantaneously become the range of f inverse. Here. So nothing to do. Just this one I write down only. Like range of f inverse. But the range of f you have to evaluate. So you can see what I wrote here. Now, sine x over 2, when your x is in between 0 and pi. So what's going to happen? This x, or rather the theta, right, will range from 0 over 2, which is 0, to pi over 2. I repeat that again. The angle x over 2 will range from 0 to pi over 2. Then 0 to pi over 2 is the first quadrant, what? So first quadrant, your sine is going to give you 0 to 1. So if your sine is going to give you the range of 0 to 1, you times 2, right? So it's like you stretch the sine function. So therefore, it becomes 0 to 2. Then after that, you go and plus 5. That means you shift up the whole interval by 5. So therefore, the range of f is 5 to 7 then. Okay, just analyze step by step from the transformations. And then this range of f becomes the domain of f inverse. So this is something that we discussed before, right? Because in the function and its inverse is reflection over the y equals to x. So because you reflect over y equals to x, so what's going to happen is that your domain will become range, your range will become domain. Is that alright? Any questions? So certainly you can plot f and f inverse into decimals and observe the nice symmetry. Only when you observe the nice symmetry, then your inverse is correct. So that's for question 9C. So do I need to do 9A or B? No? Yes? All good? DIY? Any questions? A or B? No need. B. B. Okay, so for B, right, is basically repeating the same procedure. So let y, so this one equals to y. Then after you have to isolate x, correct not? So that means you get root, so you reciprocal both sides. Can reciprocal both sides. So then subsequently you just square both sides. So 1 over y whole thing square is the same as 1 over y square. Okay? So this one just square both sides. So then from here, right, you have your 2x equals to 1 over y square plus 3. No objections, right? Okay, then you isolate your x by just dividing by 2. So x equals to 1 over 2y square plus 3 over 2. Is that right? Okay, so therefore this is the inverse function of y. Because it contains a y inside. X equals to f inverse of y. So then, of course, typically they want the f inverse of x. So it will be 1 over 2x squared plus 3 over 2. So this will be the solution for f inverse. Is that right? So then talking about the domain and range, because the question did not give the prescribed domain, so there will be some natural domain that you can evaluate. So from here, right, notice that the domain of f is, so because of the root expression, so the root expression, right, cannot be rooting something that is negative. So by right, your 2x minus 3 got to be more than 0. But you cannot have division by 0, right? So you cannot have 1 over 0, right? So that means 2x minus 3 must be strictly more than 0. Okay? So is 2x minus 3 more than, cannot be equal to 0. Because if it's equal to 0, then 1 over 0 undefined already. So therefore, this guy, right, is going to give you the domain of, so x is supposedly more than 3 over 2. So therefore, let me write it as 3 over 2 to infinity. Is that okay? X must be more than 3 over 2. Strictly more than. Any objections? Okay, so then what about the range? Because you have 1 over root, cannot. You can go very close to 0, but cannot be exactly 0, or else your f undefined already. Then the fella, which is the root expression below, cannot be negative what? So therefore, the range of f, right, is, So this guy cannot be negative, but cannot be 0 also. Because it needs this expression to be infinity, so that 1 over infinity is close to 0. So which means the range of f, right, is 0 to infinity. Okay? So you must understand that this guy can be very small. Small positive. So when this guy is very small, you will get infinity. 1 over 0, 1 over something that is very small give you infinity. This thing can be very big also. 1 over infinity will give you 0. So it has to be 0 to infinity for the range. So once you have that, right, then you can write the domain already. The domain of f inverse is 0 to infinity. Okay, because you sort. Then the range of f inverse is 3 over 2 to infinity. So you just sort. Is that right? So for function inverse, never ever analyze the domain and range from the function itself, because it is a function that is reflected. It has to get reflected from the original function f. Any objections? Okay, so I'm definitely not going to do A, so that you have something to DIY. So then we are left with question 10. Okay, question 10 I went through the earlier class. Okay, so this is like another modeling problem whereby the inverse of this function tells you something that you can make use of. So it's talking about the investing, whereby you have this compounding returns. So there is compounded at the interest rate, the annual interest rate of R%. So like for example, you go and buy the SSB bonds or whatnot, right? Some bonds lah. So typically they will pay you a certain percentage per year, okay? So initial investment P, because annual interest is R ma. So that means you can imagine, if after year 1, right, then you must get back your principal plus the interest times the principal. So therefore, after 1 year, you will get P times 1 plus R. Understand, right? Then if you were to repeat for the second year, but for the second year, the new principal is P times 1 plus R ma, is this thing. This is the new principal for year 2. Then you take this new principal, you times 1 plus R again. Because obviously you're going to get back your original principal, and then you're going to get back your return R. So therefore, it's another multiplication by 1 plus R. So when you do that, right, it's actually a square. So then you see how come the t down there at the exponent, right, comes about already. Because you are just, every year, you are just having this 1 plus R return of the previous principal. The principal at the end of last year. Okay? So hence you have this expression. So then what's the objective here? Now, because this calculates your accumulated amount by the end of year t. So here you're supposed to determine the inverse function and then describe its use in layman. So let's address the math first. So to get the inverse function, really, you just want to get t of a, right? Because previously, like, y of x is the function. So x of y become the inverse. If you didn't realize, like here. Correct or not? Y as a function of x is the function. Then x as a function inverse of y is the inverse function. So you basically just sort the x and y, the input and the output. So the same thing appears here. So now, input and output sort. So input originally is t, output is a. So now what's the inverse function? Must be output being t, input being a. So which means that you isolate the t. Okay, so I let a equals to this expression. So I isolate t by just making use of the ln expression. So you can see that I can divide by p first. Then there's a t here at the exponent. So I ln both sides so that I can bring down that t. So, yeah. So after I ln both sides, right, I bring down the t. Then I just take division by ln 1 plus r. You see? So then I get a result already. So t is just equivalent to ln a over p dividing by ln 1 plus r. Okay, so in other words, I can also write it as log of base 1 plus r of a over p, because this is actually coming from the change of base formula. Okay, of course both you will give you the same result. Okay, so what is the use in layman? This is, okay, so what's the accumulated amount? Accumulated amount is that, oh, I give you principal, I give you the interest, right? Those are parameters that are defined. Depends on your investment scheme, for example. Okay, so now I know that by year t, I can get this amount in my investment. So this is the purpose of a of t. So what will be the purpose of t of a then? Now you look at the input is a, the output is the number of years. So in other words, right, is that I want to get this a, I want to get this accumulated amount. Then I'm asking the question, right, what year will I get it? After how many years will I get that accumulated amount? So this is something that is very practical because it calculates the number of years required for the accumulated amount to reach A. Okay, it's something very practical because if you want to so-called plan for your retirement or something, right? Let's say you want to plan for, let's say you want to buy something. Okay, you want the accumulated amount to hit a certain value before you can use the accumulated amount to buy something that you want, for example. Let's say your house or something. Okay, then the T of A will be handy. So you need the inverse function, right, to assist you to calculate. So this is like financial planning, if you will. So therefore, how to get the domain and range? So same thing, right? So what's the natural domain? What's the logical domain, in fact? The logical domain of the accumulated amount, right, refers to the t values. So upon investing, it will be t0, t equals to 0, year 0. Then you can keep on having the investment until forever. Okay, assuming that you can keep the investment ongoing for your future generations if you like. Okay, so therefore, domain must be 0 to infinity for the input t. So what's the range for the accumulated amount? The accumulated amount, you start with principal p, right? So therefore, you're going to get increasing all the way to infinity because it's an exponential function, right? It's an exponential function because your input is at the exponent. So it can grow all the way to infinity after long enough time. Okay, because you start from the principal, so it's lowest at principal. So then what do you do? Just swap, swap. You see? So the domain of t, domain of the inverse function is just p to infinity. Range of the inverse function is just 0 to infinity. Any questions? So this question is telling me, right, that I cannot make a loss, right? Because my accumulated amount will be always more than p, I cannot make a loss. P to infinity, At most I break even, Okay, I cannot make a loss. So this makes sense, if you can only make a loss if your return R is negative. But if your return R is negative, why would you want to invest in that scheme? Okay? So therefore it makes sense to assume that R is positive. So that's for question 10. Final question, 11. So I got requested to go through part A. Okay? So this one is similar to the lecture example. So we can just do the transformations accordingly to this sequence. Okay, as I mentioned, this is a recommended sequence. You can see follow generally, okay, the order of transformations. Right, in some cases, you can swap some of the order. Like for example, in some functions, right, you can actually do B first, then you do A, that kind of thing. Okay, but generally, right, if you follow this sequence, you will always get the correct answer. Okay, without the so-called complications of special cases. So therefore, you start from you start from modulus x. You're trying to get this y of x. Okay, so you just do step by step. So you see, you want to get mod 2x minus 4, right? So there's a 2 here, So obviously from mod x, you try to get the mod 2x first. This 2, okay? So this is the first step, mod 2x. But mod x is just this blue V shape. So therefore, y1 is mod 2x, So what is mod 2x? Mod 2x is that your function, right, gets stretched vertically, or in other words, it gets compressed horizontally. It's the same thing. Because 2x is more than x, So therefore, the gradient of the line must be steeper, as you can compare from the green and blue lines, the green and blue grass. Then after that, you must get 2x minus 4. But 2x minus 4 is the same as 2 times x minus 2. Okay, so what's the deal here? How come I do it like that? Because x must change to x minus 2. X change to x minus 2. Okay? So that you can get this 2x minus 4 inside this modular sign. And the effect of transforming x to x minus 2 has the effect of horizontal shifting. So x become x minus 2 really means shift to the right by 2 units. So your y2 shift to the right by 2 units. So you can see the x-intercept now become 2. Then after that y3, right, you try to get this negative sign, which is your c lah. So therefore, you have a minus sign to this whole thing. So obviously, you just reflect the orange line over across the x-axis to the red line. So that's your y3. Then you have a minus 1 here, right? So you minus 1, you must bring down the whole graph by 1. So the black line will be your output y of x. Okay? Just by shifting the whole graph down by minus 1. Is that right? So from there, you can identify the domain and range already. So the domain of y will be R, right? Because you can see that your x can be anything, and you'll still be able to calculate this number. But the range of y will be from minus 1 to minus infinity. Okay? So minus infinity to minus 1 inclusive, because you can hit minus 1. Is that right? Any questions with the transformations, A, B, C, D? So certainly if you plot the graph out in Desmos, you will see the more accurate drawings, more accurate graphs. Okay, but you would not deviate too much away from what I've shown here. So that will be for 11A. So I'm not going to go through 11B, or else you've got nothing to do. Okay, so you go through 11B on your own, and then if you want to inspect, you can check the graph through Desmos. So that will be the end of tutorial 1. Okay? Any questions? Any part or concepts you want me to clarify? All good? Okay? Yeah, so you all guys know about the recordings, right? Did I mention this to you before? I already announced on the recordings before, right? Okay, good. Yeah, tutorial recordings is also in the same X site, Echo 360. So you go to this guy, right? You'll be able to see all the recordings of our, you see, okay, so this one is for the earlier class at 10 a.m. So you see this being highlighted in white. So this one is ready to view. Okay, so all the black ones that you cannot view yet, because this one is ongoing, is your class now. Okay, then these are future classes. So therefore you can view the recordings for our past classes already, right? So if you want more details on the, maybe the tutorial questions on the earlier class, you can look at the recording here, right? Okay, so today I won't go through the new material, right? I think it's better that I go through next Thursday together with the other class. Okay, because the concept of limits actually is something that we have seen before, but maybe I should go through together with the whole class. Better that way, okay? No questions, and then I'll end the class today. If you have any problems that you want to see me personally, you can come forth, okay? So that's all. You'll get the writings uploaded soon. Yeah, and by the way, your quiz, quiz 1 is week 4, so next week is week 3. So what's going to happen is that I will be uploading a mock. Actually not mock, it's basically past year quiz. Okay? So past year quiz questions, right, you go and go through. I won't upload the solution yet. So solution, I'll upload in week 4 itself. Okay? So week 4 during lecture, you will do your quiz, which is on Thursday. So I will probably upload the quiz solutions on Monday, something like Monday. Okay? But the quiz questions will be available, I think, after today, later on. So you have one whole week to try out the quiz question on your own. Then after that, you verify against the solutions I post. Infinite attempts is just a PDF. But the answer will not be given to you. Right? Only later. Okay? Because I want you to try first.